hopefully, because I've been having the same morning. I think some of you are. All right, so mixed ANOVA, final and last ANOVA, and then we will be done with ANOVA, and we will start correlation, regression, and EFA. So the last section is one of the shortest ones, just because of timing with Thanksgiving and everything. So we're going to have, I think it's just 3 chapters. Still a lot, because EFA is pretty different, but this is definitely the biggest one. This take-home test is open. It will take you a while to run because there are either 4 or 5 ANOVAs, so don't wait on that one. And then homework and stuff has been updated pretty quick, but I haven't uploaded the rubric yet. Okay. So you should have grades all the way up through the last lab. All right, all that being said, let's talk about what is a mixed ANOVA. And since we've covered the math and like how to do all this stuff, really today is just an example of how one of these works. So short day, yay. But mixed ANOVAs are when one of the independent variables is repeated and one of them is between. So mixed, it does one of each, at least one of each. We're not going to do 3-way ANOVAs, just stick with the 2 ways. But anytime you have at least one of each, it's a mixed. Okay. So since we're dealing with repeated measures, we will melt. It is easier than last week, so that's good. And you still have to screen everything in wide format. So we're going to check for accuracy, missing data, outliers, all still in long format. That says long, that should say wide, typo. Do all of that in wide format. Check for your assumptions, remembering that additivity is just basically make sure R isn't 1. Okay. So it can be just less than 999, or it just doesn't show up as 1 on that symbols for numbers table. It has to be normal, linear. For homogeneity, now we're going to have Levene's and Mauchly's, but we're going to have to trick ezANOVA into giving it to us. This is the one bad thing about ezANOVA, is if you run a mixed design, it does not show you Levene's. So we're going to have to kind of cheat a little bit, and then homoscedasticity. Okay. So these are your normal assumptions. Now on the test, you have a data set that you're going to check. You're going to run 5 or 6 ANOVAs on, but we're going to data screen the whole thing all together. So you don't data screen it for each ANOVA, you data screen everything at the front, and then run the ANOVAs at the end.
Data screen it in the wide format?
Wide format, yeah. And you'll only have to melt if it has repeated measures, so sometimes you won't end up melting. And then my recommendation from the last test, the thing that was a struggle with the graphs, is create yourself little data sets for each ANOVA. So when you get to like ANOVA 1, make yourself a smaller data set that's like hypothesis 1 data, that's only the columns you need. That'll make melting so much easier. And it should solve some of the issues you had with the graphs as well. Okay, that makes sense to people? Did I explain that well enough? Yeah, so make yourself little temporary data sets. So, appropriate for today. Today really should have been the Halloween one, but we're going to do if personality, so charisma level, which is listed in the data set as none, medium, and high, but from the book it's dull, some, and high charisma people. The gender of the participant, predicting kind of speed dating. So in speed dating, if you aren't aware, they have 2 sets of tables and people kind of rotate in and out, and you rate the different people you talk to, and then you might end up on a date. So the dependent variable is rating. So 0% would go out with, again, 100%, yay, things are wonderful. And we're seeing if the date's charisma and the gender of the person makes a difference. Okay. So genders between subjects, I can only be one gender. This is not gender of the person that we're talking to, this is gender of the rater. So I can only be one of those. And personality is a repeated measures. I'm going to see all 3 types of high, low, medium, high, low charisma. So we're going to have to melt personality but leave gender alone. So this, in theory, could be a double repeated if we were rating both genders. But the gender is of the person doing the rating, personality is of the person being rated. So we're going to have our participant number, but I don't have to create a new variable in this case. Since I only have one repeated measures variable that I'm going to melt, I don't have to make a new column. The only time that you have to do that weird column thing we did last week is if you have double repeated measures. So if we had a three-way ANOVA that had two repeated components and a between subjects, then we would have to do that, separating the IVs thing. Okay, here's another little thing I meant to take off. You don't have to save the output. You can, but you don't have to. So let's look. Tell me that they're not having problems with Studio today, because I got enough problems. All right, so while I get all of my packages installed, what you want to do is make sure you get the data set installed. Or loaded, not installed. Loaded. Okay, one more for easy. Okay, good grief. Okay, so we have this data set. Stupid thing. For gender, I took a gender, high, medium, and no charisma. And remember that the numbers here are their rating of the date. And it looks kind of like they've averaged them. This is also made up data, because normally you wouldn't expect people to give you percents of points. But let's go with it here. I'm going to fix my gender problem. So call names, name of the data set, so mixed, square brackets 1 equals capital G gender. If I just fix my gender problem, which hopefully we will.
I don't think it was capital.
Yeah, it's capital. I left a note like data screening is going to go here in, oh, it says long too. I must have been on something last night. How about wide? Gracious. Wide format. Screen first, then melt. At least I did it consistent in both of them, incorrect, but wide format. Remembering that additivity is that R should be less than 1. And then we have that same thing for power that we did last week. We figured out the minimum value of the absolute value of the correlation table, which we'll use to estimate how many participants we need. And that's going to be 0.01. So some of these columns are very, very not correlated. Because it's fake data. All right, so let's add our participant number. You have to add this before you melt, or that's going to mess up your repeated measures component. Remember, if you try to use EZ and you don't have a repeated number under participant number, it's going to be like, what are you doing? Then melt. So you see now, I've got 2 here under ID. So I've got my participant number and my gender. So make sure you leave your between subjects variables here under ID. And then our measured variables are the 3 that we're interested in. Now the problem is that when you import character variables and they come through as factors, they import in alphabetical order. So I've got high, medium, and none. It's not really the order I want them in. So I'm going to rearrange the order of them. So this kind of comes back to something we did a couple weeks ago. And I'm going to relabel them so that the labels are things that will print nice on a graph. So first thing I'm going to do is change the column names to something more useful. So I've got participant number, gender, charisma level, and their reading. And then rename them. So remember, we talked about renaming. I said you only need the levels command, or reordering, sorry. You only need the levels command. You just put them in the order you want them. But in this case, I want to reorder them and give them new names. So I've got levels and labels. And so this little section here basically is just kind of a restructure and a relabel of the data set. So that's just for me later. Like, okay, I've got these in the right order. I don't have to screw with them on ggplot again now. And I've got column names that make sense to me. Okay. So the basic code for ezANOVA and a mixed ANOVA, hopefully this is going to be kind of obvious given everything we've done, is data equals data, dv equals dv. Within subject ID is always participant number unless you decide to call it something new. Within, between, detailed, and type. So now we just have one of each. Now, in a perfect world, that would run. It would give you Levene's, it would give you Mauchly's. Life will be great, but it doesn't. So, for some reason in a mixed design, it just doesn't give you Levene's. So we're going to trick it. You're going to run that test without the repeated measures line. It's going to give you an error. That's okay. So all I've done here is take out the within component. So it looks like I'm just doing a one-way between subjects. It doesn't like that too much because it's figured out that participant number has multiple lines, and I only told it that they were between subjects, so it's like, what are you doing? Why are you doing that? So it gives you a warning, tells you should do something else. But I'm not really interested in the ANOVA, I just want Levene's. And Levene's is not significant. Woo! So each gender has roughly equal variance. So you will get an error, just ignore it. Unless your error is, hey, this isn't running. Then that's a different problem. Now, we'll run the real ANOVA this time, and we'll get Mauchly's. But what's going to happen with Mauchly's is you won't see anything for gender, because gender is between subjects, so it ignores it. It actually has nothing to do with the fact that it's two levels. It's between subjects, so it ignores it. It also has two levels, but unrelated things here. You do get information, though, for the interaction. So we'll see just charisma, and then the interaction. Because the interaction includes the repeated measures piece, so you're going to see the correction for that. So you should always get at least two, unless they only have two levels. And then you would just see the interaction. So the question is, why don't I get Mauchly's in my output? And the answer is because it has two levels, or because it's between subjects. Oh. So to run that, this time it's the full ANOVA. So I've got both my within and between line, so charisma and gender together. This is the real ANOVA. And even though there are a lot of stars going on, it's not significant. So see, I've got charisma here, and my p-value is not significant. And then gender by charisma here, and it's also not significant. They're not normally going to be exactly the same. That's one problem with making up data, is sometimes you make it too perfect. So this is just due to the fact that it's made up. They don't always come up to be exactly the same. If I wanted to correct, I would use Hunfeld, because they're both over 0.75. So I would use the Hunfeld p-values, which are here. But I'm not. because I don't need to. But I don't think we've seen an example where they were over 0.75 yet. So here's one where they are. Now, since I don't have to do anything, I can just look at my ANOVA output. The intercept line we're still going to ignore. You don't want to look at that. Gender is not significant. So men and women overall are rating their dates about the same, which is good. Okay, so there's no overall differences in gender. There are differences in charisma, which you would expect. Right? So probably that low are getting rated the lowest and high are getting rated the highest, but we have to check that. But most interestingly, there's an interaction. So there's something about the combination of gender and different levels of charisma that change people's ratings. Okay. These are very big effect sizes, again, made up data. So I just wrote out what those would look like. So no effect for gender. So this is something new. We have very, very, very small Fs or eta values. You can list them as less than 0.1. Sometimes you'll see people write them like this. I really hate that because it doesn't tell me what the degrees of freedom are. Okay, yes, anything less than 1 is never going to be significant. But at least tell me the degrees of freedom so I can tell if you've done what you said you did. So we're going to list them more like this. So give exact Fs. If they're less than 0.01, you can do it like that. Because you always want to give people more information so you don't look like an idiot when you don't have something you need. All right. So if I wanted to analyze the post-hoc, the main effects, what would I do? Well, for between subjects variables with more than 2 levels, so not this example, gender only has 2, so I wouldn't do anything. It's not significant anyway, but if it was, it still only has 2. I would just use independent T with Bonferroni. So this is why on all of the homework it's been like, what post-hoc are you doing? Why? Now it matters. You have to pay attention. So for between subjects variables, it's independent T. And pairwise.t.test with paired equals false. For repeated measures, variables with more than 2 levels, in this case we would have that. Dependent T. Cutting and pasting, you guys. Be sure paired equals true. I will upload the corrected notes here in a minute. Good grief. Sure, fine. Paired equals true.
It wasn't even that late.
But sitting in a tin can in a lightning storm. They don't let you off the plane. They're like, we're in an aluminum machine. Lightning outside. Why? How is this safe? Either way, dependent T, paired equals true. Let's make the graph. So all this code is the same code we've been using. So the big thing about two-way ANOVAs is the bar graph code is actually the same for all of them. You just have to have melted data. And so really what you're doing is you're just changing out your aesthetic, like which one are the IVs and DVs. You can switch the X and the fill if you don't like that combination. Right. And the X and Y labels. I had already fixed my labels down here up at the front because I wanted to reorder them anyway, so I didn't have to fix them again down here. So if you're going to reorder the levels to make them appear correct, just go ahead and fix the way they look, because then you don't have to do it in ggplot. But looking at this graph, the interaction hopefully is fairly clear what's going on. Right? you're getting this fan effect with the, I can draw this better. So this kind of effect. So they aren't parallel, so that's why we got the interaction. They cross, and they would. The gender ones, though, average out to be the same. So gender, there's no effect, because on average, the gender ones are fairly equal. So if I average these two together, I get the middle, and if I average these two together, I get the middle. Sometimes that's hard to see on these kinds of graphs, but on the test, what you're going to end up looking at is like a line graph like what you have in your notes. So they're not meant to be tricky like this, where it wouldn't be clear whether or not gender would. But either way, well, what is this interaction? If I'm looking here at these graphs, none females are rating lower. Medium, it looks like they're about the same. And high charisma, females are rating much higher. So they actually flip. So females start lower here, same here, higher here. That's a great interaction. One second. Because that is much easier to explain interaction-wise when they switch sides like that than when they're just different sizes of effects. Yeah.
If one graph is like somewhat unclear, could you switch then charisma and gender to make it look like a different graph, just to see if it's like a better way to look at it?
Yeah, especially making it match the post-hocs. So we're going to do post-hocs comparisons with these two bars. So it'll be 3 of them.
Because like I did that, I just switched them, and to me it's easier to read the graph
Yeah,
that way.
you can do it either way. There's no real rules on graphs that aren't the ones we've covered about labels and all that. Whichever one matches the story that you're selling. So people can, I hate to put it that way, it sounds like cheating, but if I'm reading the results section, I want to be able to look and see that in the graph. That's why I always talk about making it match your post-hocs. Because then the post-hoc is these two. Yeah.
So when I look at the graph, so like when you move from none to medium, it's just a level change. So you just move from like none to medium, but it's still a null. So like all you can say is like maybe it's an effect. But if you move from medium to high, it's a complete condition change. So like maybe there's an interaction. Is that like the right way to think of it?
I wouldn't mix levels and interactions, but I think I get what you're saying. The way I see the interaction here is that females are lower here, even here, and higher here. So that pattern is different.
Okay.
Yeah? Because I wouldn't mix levels and interactions.
Wait,
Because you said it's a level change and then a condition change.
yeah,
keep
just
those
like in high, so medium, it's like the only thing that changed was the charisma. But in high, both the gender and the charisma changed. So like that's a complete.
So how is it not changing gender and charisma here? Right?
Because it's still a male. Like it's still, males are still higher.
Oh yeah, but this isn't different. Look at that.
No, I'm saying, but compared to none, like.
Yep, but
I guess-
I'm not following you because they go,
Okay.
if I think about just charisma, they're going up overall on average too.
Okay.
Yeah, they're both still going up. They're going up at different rates. That's kind of what's happening. If I was going to examine just the main effects, I often just make myself only a main effects graph so that I can see it a little clearer. Or you can look at the means. Either way. Okay, so here's our pretty graph again. Now on the simple effects. So everything we've been doing has been leading up to doing simple effects for repeated measures, or I'm sorry, mixed designs. So we still have to split something first. So if you have 2 or more variables, there's always a split. And we've been doing the larger one. Okay, less post-hoc steps, more power. The part about that is that you have to figure out which type of post-hoc that means. There is nothing stopping you from running the wrong one. And the data is set up to run it either way. So you just have to be sure you understand which way you've split. So we're going to pick one variable to split and one to analyze. if I am analyzing this way, so the idea behind this chart is if I say I'm only looking at guys, that's repeated measures. Because I'm comparing the levels here, and so it would be repeated. The guys have rated all 3 charisma things. Same with females. If I split this way and compare high, average, and low, I'm comparing men to women, and that's between subjects. You don't have to make yourself one of these charts. I'm just trying to show you, like, depending on which way you split, you have a different test. So we're going to split the larger levels and create 3 little mini data sets for gender. I'm sorry, not to analyze gender. I'm splitting on the average, low, and high. Since I'm analyzing gender, that's between subjects. So when you get to the test, if you find this thing confusing, start with labeling the variables at the beginning and putting if they're repeated or between. That's fine if you put that in your test. Because then, later, when you get down to the bottom and you're like, oh, this is a mixed ANOVA, and you realize you're only using between subjects variables, you're thinking about the ANOVA wrong. Okay, so we're going to do the between subjects one because there's more levels and because we just covered all the repeated measures stuff. And this would be the summary. So let's look at how we got there. So I split on my larger variable. So I have none, medium, and high for charisma. And then I've thrown this in here a couple times, and no one's made any comments on it, but this actually gets a little easier if you want to use the width function. And what width does is it allows you to apply that data set name to every column name. The reason I like width in this situation is it is cut and pasted. The only thing I've changed is here, the width part. Like, why are you teaching me this now and not 3 weeks ago? Felt like it last night. I like width here. You could still do the none $ rating. You're not saving yourself that much time, but maybe a little. All right, so I've got paired as false because gender is between subjects. That part I did right. Well, if I run those, I get that for no charisma, men and women are rating these things differently. So if the person has no charisma, women are not impressed. The men are like, sure, whatever. Okay. If the person has medium charisma, if men and women are rating them equal, okay, so this is about 0.75 or 75% would date again. And then if we're at high charisma, okay, the women are very impressed, the guys not so much. So bad news for men with no charisma. The women are like, nope, not having this. It's still at 50%, so everything is still kind of high because people don't like to be mean. And the guys are like, yeah, sure. But if a guy has a lot of charisma, or if a partner person has a lot of charisma, women are going to rate this kind of high. Men aren't impressed so much.
Can you say one more time what we just did, like whether it was repeated measures or between subjects and line?
Yes.
Okay.
Sure. Let me back up.
Because at one point I thought we were doing repeated measures, and then I thought we were doing between subjects.
We just did between.
Right.
Because we split on the repeated component. So I picked one to split. I would split the repeated one, so the only thing I've left is between. You can run it wrong. Like, there's nothing stopping you from running paired equals true. That's one bad thing. So it's got to be between because I'm comparing men to women, and that's my between subjects variable. Yes?
Yes.
You don't look convinced. If I had split on gender here, it would have been repeated because each gender rated all 3 categories. So if I was comparing low to average for men, average to high for men, or if I was doing a trend analysis for each gender, then I would need to do repeated. That's what I actually always do in my just notes to myself is I usually have like gender between, but that one's pretty obvious, but charisma repeated. I'm going to split on charisma. So the only thing I have left is gender, and it's between subjects. So you can leave yourself notes in the code like that. I wouldn't consider that, what's the word I'm looking for here? Like leaving notes. Remember, because it's a test, you can't like leave yourself definitions of things, but that's sort of, I did it because it's between subjects, is fine. Okay, so this is just a summary of our p-values. Iran dependent T, independent D, Cohen's D, which you'll see all the code in there for. So be sure you're using the right type of D as well. So they should all match. It's a between subjects variable. I have independent T with Bonferroni and independent TD. And so it should match all the way through. And this first difference is huge, 4.68. It's a really big difference between men and women. No difference in the middle, and then a flipped difference on the other end. So these are pretty big effect sizes. Normally if I get numbers like this, I'm like, who made this data up? Okay, in real life, you don't tend to see numbers this big. Okay, so all that together, oh, here's the thing I almost forgot. So with n, when I'm calculating my effect sizes, I have to have n. And it's sort of tricky on these because men and women are separate entities, so they're different n's, but across repeated measures they're the same n. And so I put both of them in here, but I turned off the repeated measures one because I was doing between subjects. I would use the traditional like T apply, give me the length sort of thing. And it'll show me I have 10 in each group. So I have 10 men and 10 women, then that's repeated across. They rated all of them. So this is not 60 people, it's 20. But I don't want to say n is 20 here, because that's wrong. It's 10 in each group. If I'm going to do just repeated measures, I would do the length thing that we did last week. Alright. Then I ran all these, which I won't suffer you through. Let's finish with power. Be done really early. Woo! G. Whoa, let's do that. All right, so F-test, same old, same old. ANOVA, repeated measures within between interaction. Okay, this is a new one. So repeated measures within between interaction. Now it's really tiny, you can't see it. We're going to click determine and direct an inner partial eta squared, which in our example is too small to read. So let me back up. 0.68? Yeah, thanks. Calculate transfer to main. So alpha and beta always stay the same. So 0.05, 0.80. Number of groups. Now this is the one time that I think G-power just really makes sense. Because now number of groups is the number between subjects levels. There's 2, male and female. Number of measurements is the number of repeated measures levels. So there's 3 for charisma. The lowest correlation between repeated measures was 0.01. We did that during data screening. And we didn't need to correct, so I left it alone.
Okay, so that's what I wasn't quite sure on numbers. So with the non-specific correction, if you're not, it stays a 1s?
Yeah.
Okay.
Because I'm not fixing it. No. If you put the GG or HF in there, we would probably go with it because even if it's not significant and you might still want to correct for it, that would be okay. So I tend to leave it as 1 though if I'm not correcting for it.
Okay.
So let's tell me that my sample size is 4. I don't even know how that would be possible. Like 2 in each group, I guess, which is not gonna be normal at all. And so on this one, I wrote down at the bottom as a good example of when not to trust power. like mathematically speaking, I need 2 in each group to a total of 4. When we think about normality assumptions, you should really have 30 in each group, or 30 at least overall. So anytime it tells me less than 30, I just automatically round up to 30, unless it's a special population, because I want to hit that normality assumption. Right? I want to be able to use the central limit theorem if my data isn't normal. So a lot of the examples that we've had in class, it's given us very small numbers because it's fake data with really big effect sizes. But if that happens to you in real life, 30 really should be the bottom of what you would want to run. And at the very end, just kind of, this is true of all of the designs, but in this example, this is a 2x3 mixed factorial. So you can say mixed. You could even do 2 gender between by 3 charisma repeated. When you get to Mitchell's class, he'll want you to do 2 by 3 with repeated measures on the last factor is how you'll see him write those. For me, levels by levels, mixed. That's good enough. You have 2 main effects F, 1 for the interaction, so you have to have at least 3 F values in any of the write-ups you've been doing. What type of post-hoc test, independent T, Bonferroni correction, are post-hoc values? You can put those in a table. That's fine. And then some sort of figure. So on all of the write-ups, there are no write-ups on the test, because that would make it way too long, but on the write-ups on the homeworks. Yes, that test is long enough.